Hello, welcome to another interview preparation question. In this occasion, we are going to solve a tree question. So we have basically an input of an array string, and each string contains different people. We interpreted this as the first one. It is the father, and the other ones are his children. So we want to take different strings, get that information, and create a tree structure. And then also we want to print the whole tree. We need to find the root, print the whole tree, organize. So each level gets its own his own indent. Yeah, so we want to solve this question. Okay, so first of all, I think we need to implement some classes. So maybe we could create a class, a node, and we could also have a class family tree. Yeah, so in our class node, we're going to have a variable. Well, it could be like a let or a variable. Okay, maybe let or variable. Let's name. A name is going to be on a string. We're going to have the name. We're going to have let parent. Parent, it is going to be a node, an optional node, because the root could have a parent as nil. Then let children, and children is going to be an array of nodes. Also we need a level, an int. We could initialize this level as like -1, maybe. We could initialize the parent as a nil, and we could initialize our children as an empty array. Okay, and we could create an init, and this init is going to have a maybe name. So we're just going to make this to initialize the name for the person, and that's it. We just init with the name. That's it. And maybe we could create a couple of methods. So, example, it will be useful a function set parent, and this parent is going to be a node, and parent is going to be node, and another function at children, our child. Also, it is going to be a node, and for that, in children.append, we're going to append that node. Okay, that's good. Also, maybe a function update level from parent. Maybe a function update level from parent. We don't need any of this. And maybe we could guard node parent. We need to make sure that we actually have parent. Maybe else. Maybe we could print like no parent. For nodes. Something like that. Something simple. Yeah, so we actually have the parent. And for that parent, we're going to do this. We're going to make this level equal to node parent. I'm going to take that level and we're going to add it 1. Yeah. Yeah, so we have a function that calculates the level from the parent. So the basic idea is that we want to get the node. First of all, get the root node, calculate that. That root node is going to have a level 0. From that, we calculate all the other levels. So we have the whole structure, and then we print that. That is like the idea. Okay, so I think for now, that's our class node. Then our class family tree, what is it going to have? We could have like a dictionary, so maybe call it like let's, yeah, maybe this should be variables because we're going to modify that before, and name it doesn't get modified, so leave it like that. And our family tree, also a variable, a tree, and that tree is going to be a dictionary from string to a node. So we basically want a dictionary that relates the name for each node to the actual node. So we could get the actual node easily without any problem. And also we're going to initialize this as an empty dictionary. And what else? What else? The dictionary. We have the nodes, we have everything. Okay. So we want to init. Yeah, we want a function. Basically, we want a function that gets a string and add this to the dictionary if they aren't already added, and just set parent and children accordingly. We want that. I think that's our main function there. If we have that function, everything should work fine. So let's just create a function like add string to tree, or maybe parse. Yeah. We're going to have an input of a string. Okay, what we're going to do. Okay, we want to split our string so we got each people. So maybe it could be let's, I think, let members be equal to our string. We're going to split. I think the separator is going to be a comma. I think that syntax it is correct. So from that we got substrings. So from that substrings we want to like to trim. Yeah, but to trim we need to map this. Okay, maybe we could create a map. So we have a string from that, and from that string we're going to trim and we're going to trim yeah, I need to remember this. Yeah, so I think we have an in and it will be like white spaces and new lines. Okay, so for that we got the members. They are strings, not substrings, and we remove the white spaces, so we could remove this one if there are or not, maybe some new lines. So yeah, so we have the members. I think that's correct. Now let's just do this. So we want to add if they exist. Yeah, I think another function could be useful. So function get or create node. So I want to get our node if it exists in our dictionary, and if it doesn't exist, we want to create a new node. Okay, and we're going to do that from a string, maybe a name. So that is more readable. And from the name, we are going to have that. So if let node be equal to or tree from that name. So if that exists, just return that node. Okay. If not, we are going to create a node and return that. So maybe return node from that name. Yeah, a new node. And that's it. Yeah, I think that looks good. Actually, we need to return a node. Okay. Now, from this member, we're going to be this, let parent be equal to get or create node from members. And we're going to take our first member. Yeah. I think that should work. And maybe for in for I in one up until members count. We want to get the child, so let child get or create node from members and we want the I member, so we have the child, and let's just do this. Let's just child dot set parent is going to be our parent, and parent dot add child it is going to be our child. So we create this and we add the child and the parents. Okay, I think that looks good. So we got get or create nodes, we have the parse, and we also could create a function print the tree. Yeah, our tree actually should have a root. Yeah, it could have a root. Okay, so we have this part function parse string to tree, and maybe another function called we need this input, so maybe I don't know, parse array to tree, and we're going to have an input. We're going to leave it like that. And our input is going to be an array of strings. Yeah. So for string in input, what we're going to do, parse string to tree. Okay. Okay, that's it. Yeah, it should work. Okay, so maybe let's just separate this. Let's just say that these are the classes, and let's just delete family tree. Let's just create a family tree. Yeah, so let's just create a family tree. Family tree, parse array to tree, and our input, it is going to be this input. Okay, maybe just run it to see if we need to change something. Yeah, we need the return. Okay, it seems to be working just fine. Yeah, so that's good. So now we have all our string into our dictionary. Yeah, our dictionary. Yeah, we need to change this. So in this case, we need to add this node to our dictionary. We haven't done that. So maybe let's just do this. Let node be a new node. That's good. Then our dictionary, it is going to be for that name. So name, we're going to assign that node and then just return this node. Okay. Yeah, so our dictionary actually has all the info that we needed. Okay, now we need a function to calculate root. We need to calculate the root for our tree. So we're going to assume that all the tree it is connected, so we don't have like two different trees and so on. So we have one big tree. And let's just try to get one member from our dictionary. So maybe garlet like node be equal to our tree. From our tree we're going to have our values. So we have all our nodes, and from that we're just going to take the first one. If that doesn't work, print error empty tree and return nil. This calculate root is going to return a node. It should be a node. Okay, let's continue. I'm not sure it should be a node or an optional wrapping that node. Yeah, so we have our nodes there. So while let parent be equal to node dot parent, while that works, let's just do node equal to parent and continue. And at the end, let's just do this root. It is going to be this node. Also, let's just do this root node. We don't have a set level. No, we don't have a set level, but that's okay. So our level is going to be 0, and we're going to return root. Okay, that should work. And then we could try this. Print. No, maybe just let's root equals to military dot calculate root. and then print root. We're going to print the name. Okay, so that should work. Okay, we have an 86. So that should work. Okay, we have a Hank. So Hank, it is our grandfather. Okay, I've had Steven. Steven, it is someone else. Charles, it is someone else. Tracy, it is someone else. Well, Hank, it is just he. So yeah, so that works. Okay, everything it is working just fine. So we have our root. Then after we have the root, we could update the levels. So let's just create a function update children levels. So we have update children levels, and this is going to take a note as an input. So for child in node dot children, for that we are just going to update level from parent for that child, and also update children levels for that child. Yeah, that's good. So that calculates the levels for all our tree. Yeah. And then finally we just want to print. So function print. Maybe we could print to have it in the node class, a function that prints a node. Yeah, I think that makes sense. So function print node, and that function we're going to create a string. So let's string be equal to on string. We're going to repeat like some dots, count, on our count it is going to be the level, and then print yeah, I think that works. Print just print that and print the name. Yeah, so that prints the node. So from that we would like a function print tree, and we're going to maybe use a helper function, print notes and children, and that gets a note, and for that note let's just take the node dot print note. That's okay. And then for, actually this is the same. We need another curly braces. Okay, so for that, for each child, let's just print node and children from that child. Yeah, and the print tree, it is just print node and children from the root. Okay, and so we calculate root, then just do this family tree dot calculate root. Also family tree update children labels, and at the end family tree dot print tree. Okay, let's just run it. We need to update children levels, so maybe we could maybe we could do this. When we calculate root, actually update children levels from that root. So we don't need to call it here, just calculate root and print tree. Okay, there is a warning, an error in a 96. We have, okay, maybe just a note. And a 108. Okay, so maybe just do another guard. Let root node be equals to root. Else just do a return, and let's take this. Okay, and on use function in 115, this. Okay. Yeah, so we have our tree. So that's it. Hank, it is the root, and we have printed the whole tree. So that was the question.